Okay, sir. I got a query related with, sir, there is mean, and you mentioned yesterday constant mean, and what is difference between that? So first and foremost, I'll clarify that doubt, and then I go ahead for the further session. Now, talking about mean, here mean is nothing but mean here means overall mean of, or you can say the mean of entire series, right? But talking about constant mean here means, so talking about constant mean here, I simply said that if you classify either 4 part, 2 parts, 6 parts, whatever the parts are there, then you find equal mean. It means not only mean, equal variance also. That is difference between the constant mean for the stationarity and overall mean. So in a nutshell, we can say, if I write here, like let's suppose I have already attached my file, attach and then mint, then I have got different kind of series like Mexico, JKSC, and then this is a Beast, BSC, NGSC. If I write here mean and I write Mexico, that is my variable name, which is also series, I found this 43403. This is my overall mean. One of the criteria, one of the guidelines for testing the stationarity is either you classify 2 parts, 4 parts, 8 parts, it does not matter, but the mean has to be constant. It means the mean of first part will be equal to mean of second part and so on. That is nothing but that is all about stationarity. Here, I just yesterday what I did, I converted the series into stationarity by making a difference. First and foremost, I'd like to share what does it mean difference and what happens by converting this series of difference. So I'd like to go to this. I'm just going to Excel part to make clarity. What does it mean, this difference?
Dr. Miklesh, we can't see you, neither we can't hear you.
Okay, sir. Just I'm sharing the Excel part. I hope, am I audible now?
Yeah, you are audible now.
Okay, sir. Okay. Just I'm sharing. Uh, okay. Is it visible now? This
Yeah,
Excel file?
yes, it is visible.
Let's suppose, yeah, let's suppose I have series, and this series is a daily series like March 1st, 2nd, 3rd, and so on. And that is up to 13. If I see this, let's suppose variable name is X, 310, 312, 308, 320, and so on. These are nothing but daily wise value of series. Now I'd like to convert into first difference. Now the question is why we convert into first difference. Yesterday we discussed in a detail about stationarity. One of the criteria to make series stationary is differencing, right? That's why what we did, we simply converted the original series of Mexico into return on Mexico. It means what? We converted this series by differencing, right? The same thing we'll be doing in Excel. Like, what does mean, or what does it mean of this first differencing? First differencing is simply nothing but difference between second series minus first series. Like if I write here equal to, then the second series minus first series, and enter. And similarly, I simply drag here. It means what I did earlier was the variation. Earlier the variation was more in the sense that earlier was like 310, 312, 308, 320. So there were more variation. Now if I see the variation has been down compared to the last series. So what first difference, or maybe second difference, the calculation also second differencing. But let me talk about first and foremost about the first difference. 312 minus 31008 minus 38, then 12. It means the logic removes large variation and converts into a small. It means it will create like constant variance, and moreover, in a crux, we can say a stability in parameter will be created. Now, I hope it is okay.
Yes, it is okay. Actually, we are getting a lot of noise or audio break in between, but I hope it's okay.
Uh, Maybe, sir, maybe. Should I repeat again?
No, no, we can go ahead.
Okay. So that is the first differencing. Now talking about, let's suppose by converting first difference, if the series is not stationary, then we are supposed to go for the second differencing. Second differencing in the sense that simply difference of difference. Difference of difference here means, like I have already converted this series as first differencing, right? So I'll be making a difference of this difference series. Is it okay? Like simply I write here, I'll just write here equal to second series of this minus first series of this, and enter, and then this. It means now the second series has been created, but generally what happens in time series that data, 99% of the time we get first difference, we get a stationarity of the data in first difference. I hope, sir, is it okay?
Yeah, it's okay. We are able. And if any student got any doubt, please type in the chat box and you can ask.
Yes. Till now, any problem with students?
Well, I hope.
Shall I continue?
Please continue.
Now I'll discuss the same thing here in R, right? So earlier was like Mexico. Mexico was, if I recall, started lecture, what I did, library T series, and then I simply did what? ADF.test and Mexico series, enter. Then we found yesterday the series is non-stationary, because simply, what was the null hypothesis? Null hypothesis is simply Mexico is non-stationary series. right? And for that, sir, just a second. Give me 2 minutes. I think voice is coming from outside. I'm going to another room.
No problem.
Is voice coming right now?
No.
Is it okay, sir?
Yeah, it's okay. No noise.
Okay. So this Mexico is non-stationary, and we found from the p-value that this Mexico is non-stationary series because p-value is greater than 0.05. Now what we did, we simply did our Mexico. It means we converted this Mexico into different series. So that's why I just simply presented this thing in Excel in order to make students understand in a better way what basically software does. Software simply removes large variation and convert into a small variation in form of differencing. So that is the way through which we convert into a stationarity.
I have a question here, Dr. Miklesh.
Yes, sir. Yes, sir.
In the Excel, you just took the difference, but here in R Mexico, you have taken log also.
Yes, sir. Yes, sir. Now I'm just going to clarify this now. I hope a student will be also it will be helpful for the student if they will be writing. Then basically what happens, if our series is in terms of price, then we are supposed to convert into log differencing, number one. But if the series or if the variable is already in percentage, like in terms of, if I talk about, for example, GDP, return, return on equity, return on assets, in this case, we are not supposed to convert into log differencing. Simply we go like Excel wise, because log is used here in order to calculate return, or simply it removes large variation. But in difference, if I talk about GDP is, the range is already fixed, like 5%, maybe 7%, not going for like more than 10%. So the if I convert into differencing, it will be okay. But if the variable is like one is 10, another is 100, another is 200, then log is used. So this is difference. So the crux is simply, the crux is, if the series is given in price, we are supposed to convert into log differencing, number one. Number two, if series is already in percentage, then simply we are supposed to go for the differencing. Now let's talk about one of the topic, one of the objective. One of the objective, let's suppose my the thesis or my paper title is relationship between macroeconomic variable and stock return. Now majority of the people, they do work on this macroeconomic variables and stock return. So if I measure, or the proxies of macroeconomic variables, maybe let's suppose inflation, maybe crude oil, maybe another variable also, and a stock return, already we have a stock return. So now let's suppose I have 3 to 4 variables. One is inflation, another one is crude oil, and the stock return. The first criteria, if my objective is to examine the effect of macroeconomic variables on a stock return, then my first question will be, these variables, let's suppose I have so many variables, these variables are stationary at which level? Yeah. So first thing, we are supposed to do testing of stationarity, and testing of stationarity determines which test will be applicable. Like I'm going to attach another file, and that is the same for the same uh, study. Okay. Uh, am I audible?
Yeah, we can see
Yeah.
the
So let's suppose this is my series, and the uh, CPI, consumer price index, and then exchange rate, and then foreign exchange reserve. Let's suppose there are three variables. I'd like to see the impact of these variables. So first and foremost, I'd like to, or first and foremost, we have to examine, or we have to check the stationarity. Let's suppose attach, then macroeconomic variables, enter. So ADF test and CPI, enter. Our null hypothesis will be what? Our null hypothesis will be that CPI is non-stationary, and this CPI, the p-value is greater than 5%. It means we say that this CPI is non-stationary. Is it okay?
yeah, perfect.
So it says the series is non-stationary at level, because at level it is non-stationary. We have not done anything. But if I convert into first differencing, like ADF dot test, and simply I write here diff and then CPI, enter. Then what we found? We found the series is stationary because p-value is less than 5%. And we can say that null hypothesis is rejected. So that's why this difference of CPI is known as, or we can say this is stationary at first differencing. Stationary at first differencing is also known as integrated at first order, or you can say I1. Hello.
Yeah, it's perfect.
It means similarly we are supposed to check the stationarity of exchange rate, foreign exchange variables, or whatever variable we have. Now, I simply mention what we can say. Now, in this case, I can say consumer price index or CPI is integrated at first order. It means what? Integrated at first order means here stationary at first differencing. So let's suppose I have 5 series, 5 variables, right? The criteria is to simply check the stationarity first and foremost. If now I request students to focus on this particular like talks in a better way. If all series are stationary at level, stationary at level means let's suppose I check CPI, exchange rate, foreign exchange reserve, and they become stationary without differencing. That means stationary at level. In one sentence, if I say stationary at level means stationary without differencing. If all series are like that, then we are supposed to apply simple time series regression. Hello.
Yeah, it's okay. We are getting it.
So what I discuss, again I'm repeating, I repeat said that if all series are stationary at level, then we are supposed to apply time series regression, number one. If all series are integrated at first order, integrated at first order means if all series are stationary at first differencing, like this CPI has been stationary at first differencing. If all series are stationary at first difference, then we have to go for co-integration. Hello.
Okay, okay. And what will happen
Then
if, yeah, and what will happen if some of them are stationary at level and some are other?
yes. Yes. In this case, let's suppose I have 5 series. Some are stationary at first differencing and some are stationary at first order, without making difference. In this case, we are supposed to apply autoregressive. Hello.
Yes, we can hear you.
Is it okay, sir?
Yes, it's okay. Extremely sorry. I got a call. That's why it was some problem from my side. Extremely sorry for that.
Again, I'm repeating. Hello.
Yes, please go on.
Hello.
We can hear you, Dr. Miklesh. Please go on.
Yes, sir. Yes, sir. So let's suppose again I'm repeating the last sentence what I said. If we are having, let's suppose, 5 series, 6 series, some are stationary at first differencing, some are stationary at level, then we are supposed to apply ARDL method or ARDL model. ARDL model means autoregressive distributed line. Generally, if we have time series, if we have either bivariate time series or multiple time series, then we go for these three model. The first is time series regression, the second is co-integration, and the third one is ARDL model. And most of the time, our series becomes stationary up to first difference. Any query from students?
Yes, Dr. Miklesh, there is a query from Shivani.
Yes. In chat box?
Yeah, it's in the chat.
Okay. There is question from Shivani. What will be applied on stationary at first difference? Stationary at first difference means co-integration. As I mentioned here, if all series are stationary at first difference, then we go for co-integration, and there is a family of co-integration. There is category of co-integration. Like if we have only 2 variables and we are going to apply co-integration, in this case, we talk about simply Angel Granger co-integration. If we have more than 2 series and then they are stationary at first difference, then we are supposed to apply Johansson co-integration.
Okay,
Hello.
that's okay.
Okay. So, sir, I have gone through the title of students. When students, I think majority of the students are using
Hmm.
more than 2 variables. So obviously they are supposed to go through this criteria. First and foremost, they can see their plot with the help of ts. And then the second one is they are supposed to test the stationarity. And
Okay.
then after stationarity, they can go for the different kind of test.
Okay. So basically, you told that there are the on the basis of this ADF test, we take a decision of the three. If all of them are stationary at level, then we take a one particular type of thing. If all are at the first level, then there is a different, and mix, then there is a co-integration.
If that is mixed, then ARDL.
Then ADL, right?
Yes, sir.
So you have your video all the three, how to go for
Yes,
co-integration.
sir. Yes, sir. Yes, sir. There is a playlist of time series regression separately, ARDL separately, and co-integration separately.
We got last few minutes, 3 minutes,
Okay.
English.
Yes, sir.
So what
Yes, sir.
I will ask the students that they will take a 1 or 2 day and they will go through all your videos, because there you have already explained how to go for co-integration, how to go for simple time series and so on. And then if
जी
they have
जी
any problem, then we can call you one more time, perhaps.
definitely sir, always welcome sir, no
Okay.
problem.
So if there is anything else you need to tell them.
uh, I think these are sufficient for applying the test in any particular series
Okay.
till
So
now.
then we can take questions from the students, if any.
Okay. Most welcome for students. If anyone has a doubt, one can just share in this chat box.
Dr. Miklesh, if you allow, can I share your email ID with the second year students? These are 14
Yes sir,
students.
of course sir, of course, no problem sir.
Okay. So I will share so that they can ask directly to you.
Okay sir, okay okay okay.
So I think we can stop here, because now they have a direction that most of them have the series and they have to use this ADF test, and then they will take a decision, and those videos are available on Dr. Miklesh YouTube channel. And then I will provide you email ID so that if any doubt are there, you can ask directly Dr. Miklesh. And maybe after 3-4 days, we can invite him once again for any other doubts or any other session related to that. So there is one more question from Shivani. What about the panel data? In which circumstances we apply panel data?
Okay, now the question is for panel data simply means I have, let's suppose the CPI, exchange rate and foreign exchange reserve, but these are of only India. If I have the same CPI, exchange rate, foreign exchange reserve of more than like two country, one maybe of these three information of India as well as Russia as well as China and other country, then that will be the case of panel data.
So
And I have also,
you have your video on panel data also?
yes sir, yes sir, more than I think 12 to 15 videos are there in panel data.
Okay, that's wonderful. That's wonderful. So Dr. Miklesh, we have to stop here because it's less than 1 minute now. The session can be disconnected any time. So let's stop here. I'm stopping the recording.